Okay, this is geometry, lesson 4.6 on triangle congruence, CPCTC, and we'll get to this in a minute. Before we do that, I want to remind you of a definition that we have of congruent triangles. What do we mean by congruent triangles? And that would be two triangles whose corresponding parts, and before I move on, what do I mean by corresponding parts? Corresponding parts would be all sides, all angles. So it's two triangles whose corresponding parts are all congruent. Oops, I'll just use the symbol. So all the sides are congruent, all the angles are congruent, and that makes a congruent triangle. Now, we talked about last week when we did our little activity in class that really to prove that two triangles are congruent, we're supposed to prove that each side is congruent to the other side. You know, side 1 to side 1, side 2 to side 2, side 3 to side 3 on each of the triangles and all the angles. One angle to the other one, second angle to the second one, third angle to the third angle one. But we learned some shortcuts for actually proving triangles are congruent, and I want you to think about what those are. Why don't you hit pause and write them down? See if you can get the 5 ways that we use as shortcuts for proving congruent triangles. Okay, so hopefully you have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. And remember, there's 2 ways that won't work, and those are, I'll do those in red because they're no good. You know, you call AAA, it's bad news. I can't use all those A's. And then side, side, angle. We know what that means. That is a bad word. It's so anyway, not going to work. So now let's see, we'll move from there to what in the world is CPCTC. CPCTC, and I bet you could probably figure it out just by looking at the letters, states that corresponding parts of congruent triangles are congruent. And so that's the first letter of each of these words. Corresponding parts of congruent triangles are congruent. Now, you may think, well, that's goes without saying, because if congruent triangles are when all corresponding parts are all congruent. But the thing is, we often prove congruent triangles, but we only look at 3 of the parts, right? And so sometimes we're asked to prove parts that we have not already proved are congruent. So there's a couple things you need to know about this. Number 1 is you cannot use CPCTC to prove at the beginning that 2 triangles are congruent. If you're working out a proof and you get to the last part and you say triangle ABC is congruent to triangle DEF, and you put as your reason CPCTC, that doesn't make sense, because CPCTC is for triangles that we have already proven are congruent, okay? So you can't use that as a reason for the proof. And so I'm going to just say this. You can only use CPCTC after you've already proved the triangles are congruent. Okay? So it's very important so that you don't try and you don't want to prove the triangles are congruent with CPCTC. You use it after the triangles have been proven congruent, and then you can use it to prove other parts. So your strategy is always going to be prove the two triangles congruent by one of the methods we already know, and then use CPCTC to prove other corresponding parts. So to prove other parts congruent. Okay, so we're going to take a look here at this first drawing on number 1, and it says R is the midpoint of PS, and R is also the midpoint of QT, and PQ is congruent with ST. So it wants us to prove that this angle P is congruent with angle S. Well, what we want to do first is figure out how we could prove the two triangles are congruent. And we'll go through the proof in a minute, but let's just sort of map out what it is we're going to say. We know that since R is the midpoint of PS, we know what? That PR is congruent with RS. And since we know R is the midpoint of QT, we can say this is congruent with this. Now, at this point, you have a couple of ways that you could prove the triangle is congruent. There's really two ways you could do it right here. One is just using your other given, PQ is congruent with ST as a given, and that would be what method? That would be side, side, side. But let's say instead of that, we say this angle QRP right here, QRP is congruent with SRT. Okay, well, can we say that? And actually I should have called it TRS. QRP is congruent with TRS. And how do we know that? Because all vertical angles are congruent. So either way, that would be side, angle, side. That's going to help us prove the triangles are congruent. So let's go ahead and write out the proof. R is the midpoint of PS, so we'll start with that. And that is a given. And what do we know as a result of that? What do we know? We know that PR is congruent with RS. Now let's do our next given. R is the midpoint of QT. And so we can say QR, whoops. You know what, let me back up. For number 2, PR congruent to RS, what are we going to write as our reason? Is going to be definition of a midpoint. And then R is midpoint of QT, that's a given. And what do we know as a result of that? QR, line segment, is congruent with RT. Okay, so we'll mark those two up here. And how do we know that? Again, definition of a midpoint. Now let's see what else. We can say, how about we do the angles? Let's say angle QRP is congruent with angle TRS. Okay, and how do I know that? How do I know that angle QRP is congruent with TRS? Because all vertical angles are congruent. And so now I can say triangle QRP is congruent with triangle TRS. So I'm proving that the two triangles are congruent, and let's see, how do we prove that? Well, we have a side right here, and then we have another side right here, and we have an angle. Now, lest you think we're doing the wrong thing, because those are kind of written in the way that we think is a bad way, we can see that it's going side, angle, side, not side, side, angle. So we have side, and the angle is the included angle in between the two sides. So we're doing it as SAS, and that's from statement 2, statement 4, and then statement 5 is the one in the middle. Okay, so now we can go ahead and say angle P, this angle right here, angle P is congruent with angle S. And how do we know those two angles are congruent? By CPCTC. Corresponding parts of congruent triangles are congruent. Okay? Corresponding parts of congruent triangles are congruent. So we had to prove the triangles were congruent first, then we could use CPCTC to prove some other parts are congruent as well. Okay, let's go to example 2. Okay, now, I know that example 2 looks kind of long and hairy because there's 10 points on it. I would like you to try and do it without my help. I'd like you to think through a strategy on how you can prove, we want to prove that angle A is congruent with angle C. So you're going to have to prove that the two triangles are congruent first, and then get angle A congruent to C. So hit pause, give it a shot. Come on, give it a try, and then we'll see how you do. Okay, so hopefully what you've been thinking about is that since BD is a perpendicular bisector, we know that a perpendicular bisector is a line that is perpendicular to a segment and it bisects or intersects, you could say intersects or bisects the segment at its midpoint. So that's the definition of a perpendicular bisector. It's a line that is perpendicular, important, to a segment, and it bisects the segment at its midpoint, important. Okay, so let's just kind of map out a plan here. Since we know that BD is a perpendicular bisector, we know immediately that we're going to end up with two right angles. And I will say you have to declare both angles as right angles before you can really do anything else with them. You can't just automatically call them congruent to one another. We have to get in our statements about them being right angles. So we got those two right angles, and what else are we going to know? Since it's, D is a midpoint, we know that AD is going to end up being congruent with DC, right? And then what else can we tell about these triangles that would help us prove them? Well, BD, line segment BD, is going to be congruent with itself because BD is a side on triangle ADB, and it's also a side on triangle CDB. So it's congruent to itself. Okay, so let's go ahead and work out the proof. That's our plan. So we're going to start, let's start with our first given. BD is a perpendicular bisector of AC. And that's given. And then what do we know as a result of that? Remember, that was going to be our first part, is going to be that angle ADB is a right angle. Remember, we've got to declare it being a right angle, and how do we know that? That is going to be definition of the perpendicular. And then angle CDB is a right angle. And how do we know that? Again, that's going to be definition of perpendicular. Okay, and so now we can say that angle ADB is congruent with angle CDB. And how can I say that? because all right angles are congruent. Okay, now that takes care of that part. Now let's see what else. We can say that D is the midpoint of AC. D is the midpoint of AC. How do I know that? Definition of a segment bisector. And now that we know that it's the midpoint, we can say that AD is congruent with DC. And how do I know that? That would be because of definition of a midpoint. Now remember, what was the other thing we wanted to note was that BD is congruent with itself. So we're going to say BD is congruent with BD, and that is going to be the reflexive property of congruence. Okay, and now that we've gone that far, we can say at this point that triangle ADB is congruent with triangle CDB. And how do we know that? Based on what postulate? Would be side, angle, side. Oops, let me do that in blue. Side, angle, side. And let's just go back up here and make sure we've got our sides, our angle, and our side. So here's a side, AD to DC. Here's our angle right here. And here's our other side. So side, angle, side. And so that's statement 6, 4, 7. 6, 4, and 7. And let's see here then. Now that we know those two triangles are congruent, we can say that angle A is congruent with angle C. And how do I know that? CPCTC, corresponding parts of congruent triangles are congruent. Now I'm just writing that to remind you of what it means every time. You could just write this, it would be sufficient for me. And so you'll notice we use 9 steps. We don't even need that 10th step on there. Okay, good. I think maybe I just want to remind you that when we talk about segment bisectors, here's the set of all segment bisectors. Segment bisectors will bisect a line into two congruent parts, but there's a subset would be a perpendicular bisector, which is not only going to create two congruent segments, but it's also going to create right angles, okay, and be perpendicular. Okay, let's move on. Okay, on example 3, we want to prove that angle ABE is congruent with CBD. And let's see what we're given. We have angle 1 is congruent with angle 6, so we've got this one and this one. Angle 3 is congruent with angle 4, so we have these two. And then it says line segment AE is congruent with CD. Well, oops, as soon as I see that, I start to notice that we've got this line segment and this one, so we've got some overlapping here. And additionally, the angles that we're trying to prove are congruent. Angle ABE, right there, that's that angle. We're trying to show that it's congruent with CBD, which is right here. And so you'll notice the angles are overlapping. So whenever you have a situation like that where you have overlapping parts, it's sometimes easier to just pull out your triangles and draw them separately. Now, they don't have to be perfectly to scale or whatever, but you just want to make sure you are doing them correctly. So we have 1, we have 4, and this is A, B, E, and then the other one is going to be, we have the B up there, so CBD like that, and we have angle 3 and angle 6. Now let's go ahead and mark the things that we had earlier. 1 was congruent to 6, 3 is congruent to 4, and then we have AE is congruent with CD. Now, in just looking at that, how are we going to be able to prove those two triangles are congruent? It should be pretty obvious that we're going to use ASA for this angle side angle. So let's just go ahead and write out our proof. So we're going to start with angle 1 is congruent with angle 6. How do we know that? Given. And then next we have angle 3 is congruent with angle 4. How do we know that? Given. And then we have AE is congruent with CD. How do we know that? Booyah! Given. Okay, so now we can go ahead and say, without really hesitation, triangle ABE is congruent with triangle CBD. And what's our proof of that? Angle, side, angle. And if we want to just double check and see, here's one angle here, here's a second angle here, and here's the side right there. So statements 1, 3, and 2 will take care of our angle, side, and angle. So now that we know that, we can say that angle ABE is congruent with angle CBD. So this angle is congruent with this one. So let's go ahead and put our markings there. Boom, 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 boom. How do I know that? CPCTC. And what does that stand for? CPCTC? Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Okay, let's go on to number 4. Okay, I would like you to look at number 4 and see what you can do on your own. Okay, so hit pause, be honest, come on, hit pause, try it yourself. Okay, so I'll walk you through this. Let's look and see what we have given. We have angle 2 is congruent to angle 4. We always want to mark the things that are given. CDA, angle CDA, which is going to be all of this big angle here, is congruent with BAD, so it's going to be all of this. Now, that's kind of hard to look at, and we just talked about a minute ago that a strategy for dealing with that when you have overlapping is to go ahead and draw them out separately. And I realize it's not always going to be absolutely perfect, but this is going to be angle 4 here, and this is 2, and here's angle 3, and angle 1, and this one is BAD, and this other one is CDA. Okay, so are you with me on that? So now let's go ahead and remark those again. So we have angle 2 is congruent to angle 4, so that's this one. And then we have angle 3, this big one, is congruent to angle 1. And so now, just looking at the pictures, in order to be able to prove these triangles are congruent, what else do we know for sure is true? And I hope what you recognize is that side AD is congruent to itself. So this is congruent to this because AD is a common side for both of those triangles. Okay, so let's go ahead and do the proof and see where it takes us here. So first statement we're going to say is angle 2 is congruent to angle 4. That's a given. And then our second statement is going to be angle CDA is congruent with angle BAD. And you know what, I do want to just back up and just say something real quick, that really I should not have put this, whoopsie, not that one. I should not have put this 1 or this 3, because those were these smaller angles, 3 and 1. So really, this is just angle CDA and BAD. So forget about that 3 and 1 that I mentioned. And so we have that as given. Okay, and then we can say AD is congruent with AD. How do we know that? Reflexive property of congruence. And so what can we prove now at this point? That triangle CDA is congruent with triangle BAD. And we know that by what method? Angle, side, angle. And let's go back and make sure we have statements that prove this. Here's an angle, here's an angle, and here's a side. So statements 1, 2, and 3 help us prove that those two triangles are congruent. And so now that I know the two triangles are congruent, we can say that angle B is congruent with angle C because of CPCTC. And what does that mean? Corresponding parts of congruent triangles are congruent. So once we've proved that these two triangles are congruent, we know that all of their corresponding parts are congruent as well. Okay, almost done. So let's look here on example 5. We have that AB is congruent with CB. So let's go ahead and mark that. And then we have angle 1 is congruent with angle 2. And then we're supposed to prove that triangle AMC is isosceles. And so I ask you, if this is the little triangle we need to prove is isosceles right in here, what would I need to do? What do we know about isosceles triangles? It means they have two sides that are congruent. And so which two sides are we going to need to figure out? We're going to have to figure out this side here, AM and MC. We want to be able to figure out how they're congruent. So now our strategy is going to be, if we can prove these two triangles are congruent, then I can prove that those two sides on the other little triangle are congruent as well, because corresponding parts of congruent triangles are congruent. So just looking at our drawing here, what else can we use to help us make this proof that the two triangles are congruent? And I hope you're seeing that we would have side MB because of the reflexive property. And so what strategy is this? This is going to be side, angle, side is going to help us prove these congruent. And then once we do that, we can do the other part about the AMC being isosceles. So let's go ahead and write out our proof. So let's say AB is congruent with CB. And how do we know that? Given. And then we can say angle 1 is congruent with angle 2. How do we know that? Given. And then we can say side, let's see, what color do I want to use? We'll say BM is congruent with BM. How do we know that? Reflexive property of congruence. And now I'm pretty sure we can just say that triangle ABM is congruent with triangle CBM. And how are we doing that? Via side, angle, side. And we always want to go over here and look and make sure we have stated those things. So there's a side, here's an angle, and here's a side. So statements 1, 2, and 3 help us prove that with side, angle, side. And now we are going to say that AM is congruent with MC. And how do I know that? CPCTC. And then as a final statement, we are going to say that triangle AMC is isosceles. And how do I know that? Is definition of isosceles triangle. Okay, so there you go. That's your lesson, and we'll see you in class. Bye.